Hello, my name is Chris Eberly and I'm an applications engineer at Plexum. I'd like to welcome you to this tutorial video on creating custom components using PLECS. The PLECS library contains blocks for designing systems with multiple interconnected physical domains. Suppose, however, that you don't see the exact component you need. Using the PLECS subsystem concept, new components can be easily created and saved in customized user libraries.
Let's first explore the PLECS subsystem block. From the System Component Library, you will see that there's a standard subsystem block as well as a configurable subsystem block. If I double-click on the subsystem block, we find that this simply opens up a new schematic window containing an empty subsystem. I can then place components inside here, either directly from the library or from part of an existing design. We are going to use the three-phase LCL filter that is already available at the top-level schematic and drag these components into our subsystem. Copy and paste commands will also work for this action. We now have a subsystem defined in a second layer, but there is no connection between the first and second layers. In order to create electrical connections for the subsystem, we must use the electrical port component that is also found in the System Component Library. I will first simplify the label name and then create copies of the port block and connect them to each end of the three-phase lines. A simple way to copy a component is to drag it while holding the Control key. We can also create signal connections for the subsystem using the signal import and output blocks in the System Component Library. These are useful, for instance, to control switches within the subsystem or pass measurements from within the subsystem to the higher level system. In this case, we may want to monitor the 3 capacitor currents and will connect a signal output block to the current measurement connection of the 3-phase meter. You may have noticed that the icon for the subsystem block at the top level schematic now has terminals. When you add a port to a subsystem schematic, a corresponding terminal appears at a free slot on the border of the subsystem block. The name of the port inside the subsystem matches the name of the terminals on its mask. Let's modify the block so it's easier to understand. The size of a subsystem block can be changed by first selecting it, then dragging one of its selection handles at the corners. While you hold down the mouse button, a dashed rectangle shows the new size. When you release the mouse button, the block will be resized. Like any other component, we can also rotate, flip, and invert a subsystem block to better organize the schematic or more easily make connections. When making connections to a subsystem, however, it is often easier to rearrange its terminals than to change the block's orientation. You can move a terminal to another free slot on the border by holding down the Shift key and dragging it with the left mouse button. I will quickly move the first 3 electrical ports to the left side, the signal port to the top, and the last 3 electrical ports to the right side. Notice how the shape of the cursor changes to crosshairs as you move it close to a terminal. When you press Shift and click on a terminal, the cursor shape changes to a pointing hand. As you drag and navigate about the subsystem border, a circle shows the free slot nearest to the mouse pointer. When you release the mouse button, the terminal will be moved. We can also change the text for the subsystem label and change its placement by dragging it to a new location. While you hold down the mouse button, a dashed rectangle shows the new position, and when you release the mouse button, the label is moved. The label can be placed along the edges and corners or in the center of the block. We can also choose to hide the label of the subsystem, as with any other component, by unselecting Show Name from the Format menu by right-clicking when the block is selected. If I close the subsystem schematic window and again double-click on the subsystem block, we see that this opens the second layer. If you are just trying to better organize a model, what we have done so far may be sufficient. We can make a subsystem more dynamic and interactive though by providing it a mask. Masking a subsystem allows you to create a custom user interface for a subsystem block that hides the underlying schematic, making it appear as an atomic component with its own icon and dialog box. Many of the components in the PLECS component library are in fact masked subsystems, including all of the machine components, for example. If we look at any of the machines in the PLECS component library, double-clicking on the icon will open the block parameter window, but by selecting Look Under Mask from the Subsystem submenu by right-clicking, the schematic view of the subsystem is opened. masking a subsystem is explored in detail in the next video related to this topic. In addition to creating a subsystem by adding components to the subsystem block's sublayer, we can also create one by grouping existing blocks. If a schematic already contains the blocks you want to convert to a subsystem, you can select the blocks and connections that you want to include in the subsystem within a bounding box and choose Create Subsystem from the Edit menu or by right-clicking. PLECS then replaces the selected blocks with a subsystem block. As an example, I will do that with all of the components that make up the filter. You can still modify the circuit and add the electrical and signal ports to configure the interface of the subsystem. Finally, we will briefly touch on the configurable subsystem block that I have placed in the model. A configurable subsystem block provides multiple exchangeable implementations, where each unique configuration has its own schematic diagram or the same schematic with different parameters. I will double-click on the configurable subsystem, and we see that the only parameter is a drop-down menu containing the configuration options, where by default there is only one. This is a unique parameter for the configurable subsystem and allows the user to select which internal schematic is used during a simulation. By looking under the mask using the keyboard shortcut Ctrl-U, the schematic view of the configurable subsystem is opened. The schematic for each configuration can be accessed by the tabs on the top of the schematic view. New configurations can be added and removed from the context menu of the tab bar, accessible by right-clicking. A double-click on a configuration tab allows for the corresponding configuration to be renamed. All subsystem configurations of a configurable subsystem share the same input, output, and electrical terminals. Once a port element has been added to one of the internal schematics, it becomes available in all other internal schematics. A custom icon, block parameters, and probe signals for the configurable subsystem can be created by masking the block, just like with the regular subsystem. We will refer to the configurable VSI filter subsystem block in the second model file to see the multiple configurations. In this case, we can toggle between three common filter types for voltage source inverters: the LCL, the LC, and the L filter. As I mentioned, you will see that they all share the same input and output terminals, and everything else in between can be customized. This concludes our first tutorial video on creating custom components using PLECS. A follow-up video provides instructions on masking subsystems and creating custom library components. Thanks for watching.